We're going to look at an example that uses something called a z-score. You'll notice right here I've got the formula for a z-score. Z is equal to x, which is our data point, whatever it might be, minus the population mean over the population standard deviation. And we're going to use this to tell us how far away from the mean, how many standard deviations we are from the mean. So let's look at the question. Carrie and Joseph want to find out which one has the faster pitch when compared to their teams. Carrie's team has a mean pitch speed of 85 miles per hour with a standard deviation of 4 miles per hour. Joseph's team has a mean pitch speed of 80 miles per hour with a standard deviation of 5 miles per hour. Carrie's pitch has speed 92 miles per hour and Joseph's pitch has speed 85 miles per hour. We want to assume both populations are normally distributed, which allows us to use our z-score, and we want to know which of the two has a better pitch speed when compared to his team. Okay, so this is going to tell us how many standard deviations away from the mean we are. So let's start with Carrie, and let's figure out, using the z-score, how many standard deviations away from the mean he is. His pitch speed is 92 miles per hour. That's our data point. That's x. So we're going to have 92. If we look at the team that Carrie pitches for, that team has a mean pitch speed of 85 miles per hour. So that's our mu. And the standard deviation for it is 4 miles per hour. So that's our sigma. So let's put this calculation into our calculator. First, 92 minus 85 is going to be 7. And then 7 divided by 4 is going to give us 1.75. All right, so this means that Carrie's pitch speed is 1.75 standard deviations above the mean. And it's above the mean because it's a positive number. If it was negative, he would be a slower pitcher than the rest of his team. In this case, though, he is 1.75 standard deviations above the mean. He's faster than the majority of his team is. All right, so now let's do the same thing for Joseph. Joseph's speed, our data point for him, is 85 miles per hour, so we'll have 85. The mean for his team is 80 miles per hour, and then the standard deviation for his team is 5 miles per hour. So for Joseph, we have 5 on the top of that fraction and 5 on the bottom, which gives us a standard deviation of 1. So Joseph is 1 standard deviation above the mean. He is faster than the rest of his team, but in comparison, Carrie is 1.75 standard deviations away from the mean. He is, in comparison to his team, the difference is larger than Joseph. So Carrie has the fastest pitch in comparison to his team.